Welcome to a new unit. This unit we are going to be talking a lot about circles. Okay? So, one fact that we know about circles is it is a full rotation of 360 degrees. So, when we have our full circle, if we start here, rotate all the way around, we know that that is 360 degrees. Yes? Well, if I come in and I were to draw a diameter for my circle, now I am looking at 180 degrees because I cut my circle in half, right? Okay, well if we do that again, if I cut my 180 in half, now I'm looking at 90 degrees, right? Because that's half of half the circle. These angles that I'm creating, if I were to cut this in half, these are called central angles. Central angles have a vertex on the center of the circle. Okay? So central angles, their vertex is on the center of the circle. Okay? And what's happening when we create these angles, we're creating these outside pieces. See where our angle intercepts are outside? This creates what is called an arc. Okay? That little piece between the angles. So here we have another one, just to kind of emphasize what we're looking at here. The cool thing is our central angles, their measure, their angle rotation is actually equal to the measure or angle rotation of the arc. Okay? So our central angle is going to be congruent to our arc measure. So I was just telling you that this central angle is 45 degrees. That means that this arc measure is 45 degrees. This one is 90 degrees, so its arc measure is also 90 degrees. Pretty straightforward there. We have three types of arcs that we're going to be looking at. We have a minor arc, a major arc, and a semicircle. Okay, the semicircle, that one should be pretty straightforward. That makes sense. That's going to be half the circle. A semicircle is equal to 180 degrees. Okay, and we're going to label it with three letters. So if we were to look at this diagram real quick, just down here, H to K, that is a diameter, so HLK would be a semicircle. We're going to label it with three letters, HLK. All right? A minor arc is going to be less than 180 degrees. So it's smaller than a semicircle. And we're going to label a minor arc with just two letters. Okay, so again, looking at this diagram right here, I could say H to L is a minor arc. And I'm going to write it like this, and here, this is just an arc to show arc HL. Make sense? Okay, a major arc is going to be greater than 180 degrees, and we're going to label it again with three letters. Because if I were to say H to L is a major arc, well, H to L looks like a minor arc to me. But what I wanted was actually H to L this direction. So what we're going to do is we're going to use the three letters again, and it's going to tell me the direction. So H to J to L. That would be a major arc. It's telling me to start at H, pass through J, end at L. That creates a major arc. Okay, so now that we know our arc lengths or our arc measures, how we label them, how we're looking for them, I've got these two examples to help us relate our central angles to our arcs. Okay, so here this first one, we have the arc length VR is 135 degrees, and I have my central angle here that is 79 degrees. I want to know the measure of arc RS. So I'm looking for this measure here, RS. All right? So we got to figure out what we know. If this arc is 135, that means this angle measures 135. And here we have a diameter which creates a semicircle. So this diameter is going to give me 180 degrees, so I need to know what's left. So I'm going to take 180 and I'm going to minus the 135. And that's telling me that this angle here is 45 degrees. So this arc is also 45 degrees. Okay? Now I want to know what ST, arc ST equals. Okay, so we could do it again. I now have 45, I have 79. I could find this measure here, and that's going to give me that arc length. So if I have 45 and 79, that gives me 124, and I'm going to take that away from 180. So that tells me that this is 56. So this is 56. Central angle is equal to the arc measure. All right. Now we have most of these labeled. We can figure out TUR. So start at T, pass through U, end at R. So we're going to use all of this. The cool thing is we know a full circle is 360, and we know these two measures. So we're using everything but these two angles, so we could subtract that from 360. Or here I can see that I have vertical angles, so that means this is 45, and then I could just add up 79, 45, and 135 for that arc. Okay? So I'm going to go do that. I'm going to do 135, 45, and 79. So that's 10, 15. So this is 259. Okay? Then our last one, we have RTV. Well, R to U, that's 180 plus the 45. I'm going to go ahead and say that this is 225. 45, 56, 79, and 45 should give me the 225. All right, real fast, we got one more example. You could go ahead and hit pause right now if you want to test this one out on your own, and then come back and check your solution. So let's take a look here. So H to I. If this is 40, I know this is 40, and I know this is 180. So I have 110, so I know that this is 70, so this is 70, just like that. Boom. Okay. Then I've got H to J to L. All right, so I have 70, 40 vertical angles here. This is going to give me 70, or again, I have my diameter, which is 180. So I had 70 and 40. That one's also going to be 70. So H to J to L, I'm going to have 180 plus 70. So that's going to be 250. And then L to I to K. That's everything but this 70. So that's going to be 290. Okay, I hope that makes sense. If you got questions, let me know.